Start, sir.
Yeah. So, good morning, everyone. So this is Raghuveer Srikanth from Borabanda Girls. First of all, I would like to thank Secretary, Deputy Secretary, all the principals, and all the teachers for giving me this opportunity. Once again, I would like to thank one and all. Okay, today we shall discuss about partial fractions, which is the 7th chapter in 2A. So this carries 4 marks. So we get 4 marks question. So one SAQ from this chapter. So in this chapter, today we shall discuss about polynomials, or we'll define polynomials, and then a rational fraction. We shall define what a rational fraction, and under that you have a proper rational fraction and an improper rational fraction. And next we shall discuss irreducible factors and reducible factors. We shall see what irreducible and reducible factors are, and we shall define partial fractions, and then we shall discuss repeated and non-repeated linear factors. Repeated and non-linear repeated factors. And there are some rules. Today we shall probably discuss rule 1, which is non-repeated linear factors. Okay, if possible, rule 2. So after completing, we shall discuss this one. If possible, we shall discuss the rule 2, or else in the tomorrow's class. First, we shall define what a polynomial is. So you must have studied in the last classes or in the previous topic what a polynomial is in the previous chapters or something. In theory of equations also you must have come across polynomials. Let us define once again a polynomial. A polynomial in x of degree n, in x of degree n is an expression is an expression of the form what is it? A naught x to the power of n plus a1 x to the power of n minus 1 plus a2 x to the power of n minus 2 plus so on plus an where a naught, a1, a2, so on till an are called the coefficients of the polynomial. Yes, the coefficients of the polynomial. So we'll define what a degree of a polynomial is. What a degree of a polynomial is. The degree of a polynomial is the highest power of x is the highest power of x whose coefficient is not 0. Okay, so the degree of a polynomial is the highest power of x whose coefficient is not 0. We'll take some examples. For example, 3x to the power of 4 minus 2x square plus 1 is a polynomial of degree. What is the degree? Degree 4. So look at this one. The highest power of x, is 4. So the degree is 4. Whose coefficient is not 0? Whose coefficient is not 0? We'll see. We'll take one more example. Minus 2x is a polynomial. Is a polynomial of degree. So what is the degree you have? It is raised to the power of 1. So the degree is going to be 1. Suppose a constant expression. Suppose a constant expression 2 is there. Even this is a polynomial of degree 0. Okay, so this is what a polynomial is. Next we shall define what a rational fraction is. What a rational fraction is. This is one of the important topic for partial fractions. You need to understand what a rational fraction is. Let us define a rational fraction. Okay, first try to understand. If f of x and g of x are two polynomials f of x and g of x are two polynomials, and g of x is not equal to 0, and g of x is not equal to 0, then f of x divided by g of x, it's a quotient of a polynomial, is called a rational fraction, or it is also called as polynomial fraction, or it is also simply, you can call it as simply a fraction. Simply a fraction. Very important. If f of x and g of x are two polynomials and g of x is not equal to 0, then f of x by g of x is called a rational fraction or polynomial fraction, or simply you can call it as a fraction. Okay, in simple words, even if you understand rational, if you look at this term rational, it is nothing but ratio of two polynomials. Okay, try to remember this one, the definition for rational fraction. And then we will define what an improper rational fraction and a proper rational fraction is. So let us see what a proper and improper rational fraction is. Proper and improper rational fractions. A rational fraction we've already defined a rational fraction. What is it? A rational fraction f of x by g of x. This is very important. Try to understand what a proper and an improper rational fraction is. A rational fraction f of x by g of x is called a proper rational fraction if the degree, we've already defined what a degree is. Degree of f of x is less than the degree of g of x. The degree of g of x. Otherwise, it is improper. Otherwise, it is improper. In simple, you can say that degree of f of x is less than degree of g of x, then it is proper. It is proper. Otherwise, it is improper. So what do you understand from this one? A rational fraction f of x by g of x is called a proper rational fraction if degree of f of x is less than degree of g of x. Then it is a proper rational fraction. Otherwise, it is improper. In other sense, what do you mean by improper rational fraction? If degree of f of x is greater than or equal to degree of g of x. We'll discuss that in the later class. First, we'll discuss about proper rational fractions. Next, we shall discuss what is reducible and irreducible polynomial. Reducible and irreducible polynomial. Okay, a polynomial f of x is said to be irreducible if it cannot be expressed as a product of two polynomials. G of x and h of x, such that the degree of each polynomial is less than the degree of f of x. Try to understand this one. A polynomial f of x is said to be irreducible if it cannot be expressed as a product of two polynomials. Okay, if it is not expressed as a product of two polynomials, it is irreducible. Suppose if f of x is not reducible. What do you mean by not irreducible? Not irreducible. Fx is not irreducible. Then we can say f of x is reducible. F of x is reducible. We'll see some examples so that it will be easy for you to understand. Okay. For example, two x plus 1 is an irreducible polynomial. And if you take x square plus x plus 1 is again an irreducible polynomial. And suppose if you take x square minus 5x plus 6 is reducible. How? Since if you see this one, x square minus 5x plus 6 minus 5x plus 6 can be simplified and be written as x minus 2, we can find out the factors. X minus 2 into x minus 3. Okay, these have to be real factors. These have to be real factors, and it can be expressed as a product. It can be expressed as a product of linear polynomials. Okay, so if you look at this one, this is irreducible polynomial, and this is also irreducible because it has complex, and the roots have to be real. So if you look at this one, x square minus 5x plus 6, it can be expressed as a product of two linear polynomials. So this is reducible. This is a reducible polynomial. So we'll write a note. Take down this note. Every linear polynomial is irreducible. For example, 2x plus 3 is irreducible. Consider second, we'll write the second note. If a is equals to 0, sorry, a is not equal to 0, and we consider quadratic, ax square degree is 2, it is quadratic. Ax square plus bx plus c is irreducible. If and only if b square minus 4ac is less than 0. We'll see. For example, we have x square minus x plus 1 is irreducible. Why? Since b square minus 4ac is less than 0. What do you get? B square minus 4ac, you get it as minus 3, which is less than 0. So if b square minus 4ac is less than 0, it is irreducible. Okay, is this clear? Reducible and irreducible polynomials. Now we shall discuss or define what a partial fraction is. Write down the definition first. Partial fraction. So once we understood what a rational fraction is and what are irreducible and reducible polynomials, we can define a partial fraction. If a proper fraction is expressed as the sum of two or more proper fractions sum of two or more proper fractions wherein the denominators are the powers of irreducible polynomials. Then each proper fraction proper fraction in the sum is called a partial fraction. A partial fraction of the given fraction. Of the given fraction. Now, if you understand, if proper fraction is expressed, you have a proper fraction. Basically, you will be resolving a proper fraction into a partial fraction. A proper fraction is given and expressed as sum of two or more proper fractions. Okay, sum of two or more proper fractions. Then each proper fraction in the sum is called a partial fraction of the given fraction. So it will be more clear when we come to the problems or when we do the problems practically. I will try to explain the definition again when we do the problems practically. So now, before getting on to the rules, so we'll discuss what are repeated linear factor, non-repeated linear factors, and repeated and non-repeated linear factors together, how they are going to be. First, repeated linear factors. For example, it is very simple. It is very simple to understand. You know what a linear expression is? X plus 2 whole square. X plus 2 whole square. So this is a linear factor which is repeated twice. Okay, if it is suppose x plus 2 whole cube, it is repeated thrice. So now we'll see what a non-repeated linear factor is. It is just x plus 2. Okay, so there's no repetition in this one. Now, before getting on defining the rule, we shall there are few rules now in order to express a proper fraction as a sum of two or more proper fractions. So we shall define the rule 1. So before getting on to that, now we find partial fractions of f of x by g of x when g of x contains non-repeated linear factors. Non-repeated linear factors. We use the following rule. We use the following rule, which is we consider that as rule 1. So if you look at this one, so we find the partial fractions of f of x by g of x, which is a rational fraction, and g of x or the denominator contains non-repeated linear factors. So we are going to define a rule for this one. We are going to define a rule for this one. To each before getting on to that, we'll define a proper rational fraction. let f of x by g of x be a proper fraction to each non-repeated factor ax plus b of g of x. There will be a partial fraction of the form a by ax plus b, where a is a non-zero number which has to be determined. It has to be determined. So you have to find out the value of a. So what is the rule? Let f of x by g of x be a proper fraction, and to each non-repeated factor ax plus b of g of x, there will be a partial fraction of the form a by ax plus b, where a is a non-zero number which has to be determined. We'll see what is the form of a rational fraction and the form of partial fraction. Suppose form of, we'll make a table, form of the rational fraction. And here we'll write it as form of the partial fraction. So first, based on the first rule, suppose a proper fraction, we'll consider proper fraction px by x minus a x minus a into x minus b, and a is not equal to b. So what would be the form of the rational fraction according to the rule 1? A by x minus a plus b by x minus b. Look at this one. Rule 1. What is the rule 1? Let f of x by g of x be a proper fraction to each non-repeated linear factor ax plus b of g of x. There will be a partial fraction of the form a by ax plus b. So here we have, suppose it is px plus q by x minus a into x minus b. It can be written as in the form of partial fraction as a by x minus a plus b by x minus b. And if you look at the next one, we'll see one more. For example, px square plus qx plus r divided by x minus a into x minus b into x minus c. There are three non-repeated linear factors. Here we had only two. It can be two or more. There are three non-repeated linear. How do you write this one in the form of a partial fraction? It is a by x minus a plus b by x minus b plus c by x minus c. So this is how the rule works out. So now we shall do a problem based on this one. We shall see one problem based on this rule. Let us take one problem. Resolve, for example, 2x plus 3 by x plus 1 into x minus 3 into partial fractions. So let us see the solution. So what is the first thing you're going to do? Check whether this is a proper rational fraction or not. So a main important note is that whenever you are resolving a rational fraction, whenever you're resolving a rational fraction into partial fraction, you have to check whether this is a proper rational fraction or not. If it is improper, you have to reduce to proper rational fraction. Improper rational fraction, we'll see it in the next class. First, we'll try to simplify this. So the given fraction fraction 2x plus 3 by x plus 1 into x minus 3 is a proper rational fraction. How is this a proper rational fraction? Since degree of numerator is less than degree of denominator, or degree of f of x is less than degree of g of x. Okay, this is how you're going to define whether the given fraction is a proper fraction or improper fraction. Once this is a proper fraction, how do you resolve this into a partial fraction? Therefore, 2x plus 3 by x plus 1 into x minus 3 can be written as a by x plus 1 according to the rule 1, because these two are non-repeated linear factors, plus b by x minus 3. Say this is equation 1, and we'll try to simplify this further. This can be written as 2x plus 3 by x plus 1 into x minus 3. So what is the LCM on the RHS? X plus 1 into x minus 3. So what is this? You're going to get a into x minus 3 plus b into x plus 1. So now we have to simplify further. These two terms going to get cancelled. So what is the next step going to be? 2x plus 3 is equals to a into x minus 3 plus b into x plus 1. What are we having? So here, if you look at that, what is left? 2x plus 3 is equals to a into x minus 3 plus b into x plus 1. We are writing in the next step as 2x plus 3 is equals to a into x minus 3 plus b into x plus 1. So consider this as equation 2. Now what are we going to do? We are going to determine the values of a and b. How are you going to determine the values of a and b? With this, you are going to consider the factors of the denominator. You're going to consider the factors of denominator. With the help of the factors of denominator, we can find the values of A and B. Let us see how we can find the values of A and B. Okay. So what are the factors of denominator? X plus 1 and x minus 3. X plus 1 is 0. What do we get? X is equals to minus 1 and x minus 3 is equal to 0. What do we get? X is equals to 3. Okay, first put x is equals to minus 1 in equation 2. What do we get? Tell me. 2 into minus 1 plus 3 is equals to A into minus 1 minus 3 plus B into minus 1 plus 1. So this implies minus 2 plus 3 is equals to A into minus 4 plus B into 0. So this implies 1 is equals to minus 4A. So this implies A is equals to minus 1 by 4. So now we'll try to find out. We'll try to find out by substituting x equal to x is equals to, what is the next value you have? X equal to 3. You have put x equal to minus 1 for the first, and now we are going to substitute x is equals to 3. Put x is equals to 3 in 2. What do we get? Tell me, you're going to substitute x is equals to 3. Um, 2 into 3 plus 3 is equals to A into 3 minus 3 plus B into 3 plus 1. Simplify this further. 6 plus 3 is equals to A into 0 plus 4B. So what are we getting? 4B is equals to 9, and we get value of B is 9 by 4. Value of B is 9 by 4. So we got the values of A and we got the values of B. Where are we going to substitute? We're going to substitute in equation 1. We're going to substitute the values of A and B in equation 1. A is equals to, what did we get? Minus 1 by 4, and B is equals to 9 by 4. We have to substitute in this equation. Okay, substitute the values of A and B in 1. What do we get? 2x plus 3 divided by x plus 1 into x minus 3, and written as minus 1 by 4 A by x plus 1 plus 9 by 4 divided by x minus 3. This can be further written as minus 1 by 4 into x plus 1 plus 9 by 4 into x minus 3. Yes, sir. Okay.
Thank you, Srikanth sir. Thank you so much for your class, sir.
1 minute, I'll give the assignment and end.
Okay, sir.
Okay. So this is how you're going to resolve a proper fraction into partial fractions. So let us take the today's assignment. Problem number 1. You can consider this as resolve the following fractions into partial fractions. Let us take first one, 5x plus 6 divided by 2 plus x by 1 minus x. We'll take one more, second 2 divided by x square minus 2 into x plus 1. So tomorrow's class we shall discuss about repeated and or non-repeated linear factors, and if possible we'll discuss about the improper fractions and do problems based on this. So go through the theory in deep and practice the theory and then practice these problems. Okay, thank you, ma'am.
Thank you, sir.
Thank you, ma'am.